All right. Work on that outside. Stay with me here. I know. Stay with me. All right, the pH of water, we said. If the pH of water should be, right, what is the in pure water, what is the hydrogen ion concentration? We've already been through this. What is it? 1 times 10 to the minus 7. If it's 1 times 10 to the minus 7, what should the pH be of pure water? 7, and it is. That's why 7 is our midpoint on the pH scale. Okay? So that means that if we calculate anything, a pH that's less than 7 obviously is an acidic solution. A pH above 7 is a basic solution. Okay? So now we've seen how the math goes into all of this, rather than just measuring it and saying it. Okay? So there you go. I already talked about how 1 pH unit is actually a factor of 10 difference, so keep that in mind. Okay? It's a big difference from 5 to 4 and 4 to 3. All right. Oops. All right. So we know that our scale now goes from 0 to 14. 0 means that everything in the water had been converted to hydrogen. 14 means everything would have been a hydroxide. Okay? They're opposite ends. They're polar ends of the spectrum. All right, so here's some common substances. 1 molar HCl. Remember I said like 1 molar solutions is about where the pH scale drops off. Now you can have above and beyond that. You could have like negative values for pH. That means it's extremely acidic. But since we limit ourselves to water, and that's what's most prevalent, and these levels are most prevalent in biological conditions, the pH scale is just sort of a small sample of the concentration that we're dealing with. So this is where it ends. The pH of 0 represents a 1 molar acid solution. Okay? A 1 molar basic solution down here would be 14. That's the opposite end. Then you've got everything in between. You notice a lot of things here that we talked about unpolluted rainwater. Even unpolluted rainwater is down to 5.6 on pH. You could calculate that, but that certainly means it's acidic, right? Why is it that even though there's no pollution present, you remind me, why is rainwater always going to be a little acidic? Because what's present in the atmosphere? CO2. CO2 can react with water vapor to form what? Acid. Good, carbonic acid. CO2 plus H2O will give you H2CO3. Okay? All right. Human blood is always slightly basic. And then there's a lot of other examples here. Okay? You mean what's the pH of oranges? I'll ask you what oranges were. It's like, you got to be kidding me. It's not going to be probably as strong as lemons. Lemons are some of the most acidic fruit. Somewhere in here, I would imagine. Obviously, it's going to be more acidic than an apple. So I've not tested one. I don't know. But, all right. See, you could do a whole big science fair project there. You could just do a bunch of pH testing with your kids, but take it a step farther and show them the math and how to calculate the actual hydrogen ion concentration. And then you could make a couple of simple steps, and as long as they understand the math, they can explain it. Yeah, if they ever go to science fair, they probably won't want to.
Yeah, because they'll be burnt out by then.
All right. Now, let's look at, I want to show you another roundabout way of doing this too, in case you're not given all the information that you need up front. Calculate the pH of a 0.0010 molar barium hydroxide solution and determine if it's acidic, basic, or neutral. Now, you can guess as to whether or not it's basic or acidic based upon the compound. Okay, but prove it. Show me the numbers. All right, here's what we know, right? We've been through this before. We know that there's going to be 2 hydroxides given off when this dissolves. All right, so that means my actual concentration of hydroxide ions is not going to be this, but instead it's going to be this. Okay? All right. Now, how do I calculate pH? Can I use... Okay, that's right, but I have to have H, right? I have to have the hydrogen ion concentration. Can I figure out the hydrogen ion concentration if I know the hydroxide ion concentration? Sure I can. I use Kw. That's right. That's exactly what this problem is. Here, I want to know the pH of this solution. I'm not asking for the pOH, which exists, but I want to know the pH. That means H. I got to know hydrogen concentration. I can figure it out if I know the hydroxide ion concentration. So I set it up accordingly. I know that Kw divided by my basic concentration is going to give me the concentration of the acid. So there it is. Now all I do is, like you say, pH is equal to the negative log of whatever that number is. 2. Why is the 2 here? There's 2 hydroxides that fall off from this, right? So I have one of these guys present, but when it separates, I've actually got 2 hydroxides free floating around. So I've got to double that concentration. Okay? All right, so when I plug in the numbers and take a negative log of 5 times 10 to the minus 12, I get pH of 11.3. Now, on the pH scale, we know that that's basic, right? So this is a proof, therefore, to say that you're going to make the claim just based upon the formula. Okay, so some more practice. Can't get enough of it. Calculate the pH of the following strong acid or base solutions. Now, notice I'm going to throw this in just for the sake of mentioning it. I say strong acid and base, because what I'm going to have you calculate in this class only deals with strong acids and bases that dissociate completely. You get into Chem 2, we talk about some chemical equilibrium situations. Whenever all of the H and all of the hydroxide doesn't fall apart, and that's a lot harder to measure the pH, because you don't know what hydrogens are free floating, what ones are locked up. That gets a lot trickier. Okay? So right now we're going to stick with strong acids and bases that you know that if there's hydrogens there, they've all fallen apart and they're all floating around, so you can measure them. All right, so we got 0.020 molar HCl. Going with this right here, walk me through what would I do to calculate the pH of that solution. What formula would I use? pH is equal to what? There you go. Negative log of the hydrogen ion concentration. Because I have the hydrogen ion concentration, right? Right here. Okay, before we go show that, let's look at this. Can I calculate the pH given this information? Yes, I can. I have to find hydrogen though, right? Okay. Can I find the hydrogen concentration from this information? Yes, I can. I can do it. How can I do it? Because I know what is true. I know that Kw is always equal to 1 times 10 to the minus 14. So that means whatever concentration of hydroxide I have, times whatever the hydrogen would be, has to equal 1 times 10 to the minus 14, right? All right, so what is my concentration of hydroxide in this case? Is it 0.005? No, it's not. Why? Because there's 2 hydroxides that fall off. So what do I got to do to this? I got to double it. So what happens when I double that? 0.01, and then whatever's after it. So 0.01 molar hydroxide is what I would use. And when I divide that, I would get an answer for my hydrogen ion concentration. Then I could use negative log of that. Okay? Down here, 0.25 molar. I don't need to do all of this. I've already got my hydrogen ion down here. And there's only one, right? So 0.25. Negative log of 0.25 will give me the answer that I'm looking